record this session. Good. So we're going to look at maybe question 1, even question 2, if you watching question 2. All right, we'll try them, right? So if you have the time, please watch the videos that I posted of the 2 tutorials. I think one of them was Tuesday, one was last night. Was it last night? Today's one. I think yesterday morning, I recorded those 2 sessions and we worked question 3, question 4, and we actually went over to a minimization problem, right? And there was a glitch. I hope tonight I'll be able to point it out. The way we read off the solution for the minimization problem, right? So I hope to clarify that tonight here. I'll post this video as well, right? So watch those for question 3 and 4. So what our focus will be this evening is how to use a simplex calculator to help you quickly calculate, the solution to a linear programming problem. You will see in those videos I point out that the graphical approach works well maybe when you just have two unknowns, maybe an X and a Y. But when you have 3 unknowns, things get a little fuzzy, right? Things get a little fuzzy in that Desmos, for example, just can't graph 3-dimension functions, right? Where you have X, Y, and Z. Like in this case, you see X1, X2, and X3, right? Those are 3 unknowns. And at least the program I was using, Desmos, can do it. I think GeoGebra may. But even so, the graphical approach has its limitations. Where as you increase the unknowns, right, you are going to have trouble using a graphical approach. And what had happened is that the simplex approach was developed to deal with those because really the simplex approach makes use of matrix arithmetic, right? And what it does, it actually tries each one of those nodes or intersections or vortices of the feasible region. The process, when you look at it, you want to know how is it happening, but it's happening, right? The process has been tried and tested and it works, right? And the simplex method, well, you can have any amount of unknowns and it will churn out the answer, right? So we're gonna do, let's see if we can do at least this first one here. So, oh, by the way, when you watch that video on 3 and 4, you will see how we can actually take this worded problem, right? This worded problem and make up the inequalities, right? I did it for 3 and 4, and I remember in a video I did for the class, it wasn't a tutorial video, it was like a lecture like. I actually had a case where you have the information on a table. Because sometimes these things, when you read them, it's so wordy. By the time you read and you reach the end, you want to know what were you reading at the beginning. So sometimes the information can be captured and summarized on a table. And you can make up your inequalities based on that. So watch that video to see an example of that, right? Good. So let's take this first one. We want to maximize this this objective function subject to these conditions, right? But as I said, when it comes to the simplex method, don't do it by hand, right? Don't do it by hand. And you want to make use of a simplex calculator. I'll show you one in just a moment. Let me see if I can switch to that window for this one. Let's see. I don't know if you can write this down. Write down these things here, because when I switch to the calculator, you want to know that, well, oh, and I'm not going to use x1, x2, and x3. I'm going to use x, y, and z, right? So let me see. I think I typed it up already. One second. I have to type it from scratch again. I'm not seeing it here. Is that it? X plus 2y plus z. Let me see. Yeah, that's it. I think this is it here, right? Got it. Yeah, that's it. That's it here, right? So it's for those of you who might want to know this calculator, its name this website is emathhelp, emathhelp.net, and they have all kinds of calculators there, right? Maybe you probably use this for your matrix exam, right? Your matrix test, and you can't mind the advertisement because, well, that's what pays for the site, right? I see Henry. Henry is in the class. I think she hinted to me that she's teaching IT. And this is the kind of thing that you have to encourage your students to do, right? This is a nice little website that has a set of calculators. Got to really know your maths to write the code for it, right? And here it is. Google is putting all these advertisements, you notice? All over. And that's what pays this person. I don't know if it's a person or a group of persons, right? Anyway, that's just by the way. Good. So you type in your conditions, right? Your objective function, you type it in there. Notice I didn't use x1 and y, x2 and x3, right? I use x, y, and z, right? That's what you see there. The constraints, I think they were x1 plus x2 plus x3 is less than or equal to 122. Was it 122 or 12? You see, 122. It's 12, man. 12, 12. Mistake. It's 12. And x plus y plus 3z is less than or equal to 18, right? And you type, well, okay, you notice they say maximize. You know, you do a little bit of work there, and I go to the big M method, calculate, right? And that's what your input is. Good. So what the calculator will do, it will introduce what we call slack variables, right? Remember, look at this. Let me go back. Let me annotate the diagram. You will see, okay, x plus y plus z is less than or equal to 12. Now we want to change that into an equation because matrices don't deal with inequalities, they deal with equations. So we throw in what we call a slack variable. Because if x plus y plus z is less than 12, then if you throw in a number there, maybe this number can take up the slack then. And you will have now x plus y plus z plus a slack variable is equal to 12, not less than 12. Same reasoning goes here, right? So now that we have the inequalities in this form now, they're all equations now. We can take these equations and put them in a matrix. And that's what we're doing here. That's what we're doing here, right? Do some more erasing. Okay, this is the matrix now. Now notice here you have -1, -2, -3, and so, right? And zeros here and so. Where did we get that from? But when you do the z function, you actually take everything to one side and equate it to 0. Right? So you're starting out with saying that z takes on a value of 0. So that's why you have -1, -2, -3 instead of 1, 2, and 3, right? And there are no slack variables in the objective function. That's why you have a 0 here and a 0 here, right? These here can go as they are, right? 1, 1, 3, 1, 18. Okay, they put that, okay, that's this one here. And this equation, notice the coefficients and so, right? Notice in the first equation here, there is S1. That's why you see you have a 1 here, but 0 here with S2 because there's no S2 in it. And in the second equation, there's an S2 but no S1. And that's why you have a 0 here, but a 1 here on the S2. So this here is what you call your simplex tableau. We're not going to use the word tableau, the simplex table, right? That's a word we use every day. Before I bite my tongue. Good. And now you start the process, right? Start the process. And the process involves what? Well, you start by identifying what we call the pivot column. And how you identify that, you look for the, by the way, the calculator is going to do it all for you. I'm just walking you through the process because you need to know the process. Why I say that? In the test, I might make up questions where I might say, well, all right, which one is the, which row is the pivot row? Which column is the pivot column? And you have to know, right? Where or which number is the pivot element? You got to know, right? Good. So you have to know the process. So notice they're looking for in the Z row here, you're looking for the most negative number. That number is -3. You can see it here. So that will now become your pivot column, right? So we kind of make it into gray here. That's your pivot column. And you want to identify now what we call a pivot row, right? And what you do is you take the solutions here, 12 and 18, and divide by the 1 and the 3 here. And that's what happens at anywhere. The one with the lowest ratio, the 6 here, that will now help us to see which one will be our pivot row now. This is our pivot row. And where the 2 intersect is where this 3 is. That's what you will now call our pivot element. Good. Now, what will happen in the...
Excuse me, sir. So what you're saying is for when you're finding the column, you have to find the highest negative, and when you're finding the row, you're finding the smallest ratio?
Yes. I want to correct myself if I said the highest negative. I think that can be misleading. It's the most negative number, right? The most negative. So -3 is the most negative of the 3 of them. Because highest negative is really -1. -1 is greater than -3, right? So I'm going to use the word most negative. Or the one with the largest magnitude. Yeah, and yes. So you're right. That tells you what is your pivot column. And to know your pivot row, you look for the ratio that is the smallest. So you take the solution here, 12 and 18, and divide by the number 1 and 3, right? The numbers in the pivot column. Notice the ratios are equal to 12 and 6. The one with the lowest you'll take. If there's a negative number, forget, just disregard the negative, right? You'll see, I think in this question here, as you go down, there's one like that. Good. Now that we identify our pivot column and row, the 2 of them intersect here with this 3. This 3 now is what we call our pivot element. Our aim is to make that 3 into a 1. And the numbers above it, that minus 3 and the 1, you want to make those into zeros, right? Using what we call row operations. Because in matrices, there's this thing called row operations. We can do stuff with a row. We can divide it, we can multiply it, we can add it to another row, all kinds of things we can do, right? So notice the first step. Oh, by the way, you will also in the next table notice that this S2 is going to be replaced by Z, right? So you're actually getting rid of one of the slack variables and replacing it with one of the unknowns that we want to find, right? So S2 is leaving, Z is taking its place, as you see here. Good. So remember, we want to make this 3 here into a 1. So we divide that row throughout by 3. And the calculator actually tells you, right? It actually tells you what goes on. Oh, by the way, I don't know, the person who wrote the code is calling this last row 2. I don't know why. I mean, for me, it's like row 3, but they're calling it row 2. I don't know, something seemed glitchy about the program. I would say this is row 3, but this is row 1, this is row 2, this is row 3, right? Good. So you divide everything by 3 and you get your 1. That's what we want. Our next step is to make this minus 3 into a 0. What do we do? Well, notice what they did. You multiply and notice all your operations in this part of the calculation will involve that row 3, right? Notice now they're calling it row 3. They say add row 3 multiplied by 3 to row 1. So we take this last row here, multiplying by 3, and add it to row 1, and that will get rid of this minus 3, right? But you do it to every element here, every element. So you take this row here, this whole row, multiply it by 3, and then you add it to this row. And notice, sorry, you add it to this row. And you put the answer here. So you get 0 minus 1, 0, 0, 1, 18. So you do have a 0 here, right? That's what you wanted. Your next step is to make this one. You want to make this one into a 0. Notice what you do. You simply subtract row 3 from row 2. You subtract this row from that row, and you get your 0 there, right? Of course, these numbers are going to have all kinds of values. Well, so you do the subtraction, and here you have your desired result. You have your 1 here, and all over else has 0. Good. So your next step now is to start going, you're looking for another pivot column and a pivot row, right? So you repeat this same procedure. Notice here, you're repeating it. So you look at this first row here, and you see the most negative number, but the only one is -1, right? Good. So that column becomes what we call the pivot column. So we take the 6 and the 6 and you divide by these numbers here and get the ratios. And the one with the lowest ratio is the 9. That helps us now to identify this gray row here as our new pivot row. And our pivot element is this 2/3 here. And what will happen now in your next step, we're going to replace S1, another slack variable, get shut out now. And you're going to put Y there in its place. Right? So you're kind of heading towards a nice solution where your solution has X and Y inside. But you don't want that if you don't want the slack variables in your solution. Sometimes they find themselves there. Right. So our next objective now is to make this 2/3 into a 1. Right? Now, what do? You multiply, they say, all right. It's like you're dividing by 2/3 or you're multiplying by 3/2, whichever one you like. And this 2/3 now becomes a 1, as you see here. Well, you don't have to worry. I'm noticing what's going on. Oh, sorry. This is the one. This is the one. This is the one. So your next step is to get rid of this -1. And then later on, you'll have to get rid of this 1/3. You have to make those into 0. Right? And these are the row operations that will do that for you. Right? So add this row 2 to row 1, and that will get rid of the -1 and make this into a 0. And then your next step, take row 2 divided by 3 and subtract it from row 3, right? So you take this row, divide it by 3, down here you get 1/3. And you subtract it from this row, and that will get rid of this 1/3. And you will get a 0 here, right? You get a 0 here. So you have now your desired results. And when you look at this Z row here now, there is no negative. Therefore, when you see no negative numbers there, you have actually reached the optimum solution to your maximization problem, right? And the maximum solution is, okay, your maximum value of Z is 27. And it occurs when Y equals 9 and Z equals 3. Notice X is not in the solution, right? Because if you watch here, there's no X here, right? There's no X here. So your solution is X equals 0, Y equals 9, Z equals 3. And at this point, Z is 27. That's your maximum value. All right, so that's the procedure. The calculator does almost everything for you, even reading off the solution. However, you will learn.
So, sir, sorry, sir, I just wanted to know, when you ask us to give you the row operation, do you want us to write it as R3 minus R2, or you want to say subtract row 2 by 1/3 and stuff like that?
Um, well, listen to what has happened. Nobody reads my instruction, right? I would ask a question and I'll tell you, okay, like in the previous tests, right? I have to mark over all them tests by hand. 220 students, nobody reading instruction. This is what I tell students. I say, all right, calculate the value of X and write the number only. And I will tell you, don't put no space, don't put no comma. Write the number only. You know, people still write out the value of X is equal to 9. You're not gonna believe me. I asked them to write the number, they write in a whole sentence. So I will start giving people not for not following the instruction, right? You understand? Read the instruction. What I want you to do will be clearly written in the instruction. Right, friend? If I want you to use the word subtract, I'll tell you to write it in words. If I tell you to write, or something, there is a multiple choice, you have no choice, right? I'll be careful as to what I ask you, because I figure out Guyanese students, they don't care about instruction and so. You understand? We just, that's why we can't survive, you know, nowhere else. Yeah. People don't follow the instruction. I think I gave an instruction wire test. No commas. Guess what the person did? The person calculated the thing correctly, but the answer had to get a decimal point, 0.56. Guess what? The person didn't use the decimal point. Because they understand, I don't know if they understand the decimal point to be a comma. Right? I said in the instruction, do not use any comma. Person said, okay, no decimal point at all. So please read the instruction. Whatever I ask you, the instruction will be crystal clear. right? If I say to answer in a sentence, you answer in a sentence. But that's, remember this, they're computer marketing. Computer don't understand sentences. Right? If the answer is one, put one. Don't put x equal one and y equal one and all. If I tell you to do that, then you do that. Then people can put capital X. Some people use common X. Some people put X, put a space, then put equal, then put another space, then put the number. The computer don't understand that. It's not a forcing. I just got to mark over everything. My instructions are always very clear, but people don't bother with me. Yeah. So that's that one. Okay, let's go back. How was I saying something? So that's this one here, really, right? This first one. Uh, okay, give me a second. I want to go over to a minimization problem. As I said, there was a little misunderstanding, I would say. I think my problem, remember this is a calculator, right? That is online. And remember the calculator might put things a different way from the way the textbook does it. Right? And I think that was the problem. I'm trying to remember it was last night. And I myself got confused. And that's why my advice to you is to take the calculator and get to know it. Get to know how the calculator works. Because remember, the people who are writing this calculator might not be reading the same notes I am using, right? And they would want to write their code to display the solution differently, right? So that's what I'm saying. Don't wait for the night. I think some people did that. Don't wait for the night when it was the matrix, when we did the matrix test. Some people like to learn how to use a matrix calculator that very night. First test, I told you, I'll write out your formula. Some people like they are scrolling through to find formula that night. Yeah. You know, gynae students. And then next year it will be free education. Oh, my most shipping is going to be doing. As you're not paying, I'll money gonna pay for you. Okay, so minimization is a completely different and more complex process, right? And that's why you find that most of the time my solutions are always on maximization problem, because minimization brings in some other dimensions, right? A lot of times you're going to have situations where you're dealing with an unbounded area. If you notice in the maximization problem, the feasibility, the feasible region is always bounded. It's bounded very often by the coordinate axes, the x and y axes, and some lines. In minimization problem, very often, I'm not saying always, but often you would have unbounded regions, and therefore the solution gets a little more complicated. However, there's a little principle that is used, right? Where you transform the minimization problem into a maximization problem, right? And you proceed as normal. But it's just reading off the answer that is a little funny, which I will point out in due time. Good. As an example, okay, look at this one. So we have to minimize z equal 12x1 plus 16x2, subject to those conditions there, right? X1 plus 2x2 is greater than, notice the switch around of the inequality sign. It's greater than or equal to 40. X1 plus x2 is greater than or equal to 30, and so, right? Good. So as I said, So to solve a minimization problem in Simplex even is a little complicated. I just want to flip over to did I use the right word there? Flip over. Um, I hope I'm not using lewd words. Yeah. I want to go over to the solution in the calculator to show you how it gets a little more complex, right? Just give me a second. Let me see if I can find now. Okay, yeah, look at here, right? So it's the same problem. And notice I didn't click the maximization box, right? So I'm going to use the calculator. Notice what's going on. When you watch the solution now, you see they talk about penalizing the slack variables, right? They're not calling them slack variables, they call them artificial variables. You see there's a MY1, MY2, and if you notice the table's got minus M. It gets, look here, the solution got 40M and so on inside, 70M and all kinds of things. It gets very complicated, right? And I'm not sure whether the algebra will be managed, right? Notice in the end, you got some M's and all of that, right? And you still have some negatives here, and yet they're saying, notice you're not looking for negatives here, right? You're getting rid of all the positives and you only want negatives here, right? The very opposite. And you reach here. So that's why we're not going to use this method to, where you're going to solve the minimization problem directly, right? Yes, you can throw it in the calculator and get your answer and so on. But we are going to use the maximization approach, right? We're going to take this problem and we're going to find its dual, right? It's dual, it's transpose. And you are going to see that when we solve that, we're going to get a solution. It's just the reading of the solution is what might be a little fun, right? Good. So I'm going to go back to the problem. So here is the problem, right? Here is the problem. So what we're going to do, we're going to take these coefficients here and form a matrix, right? I don't know if you notice. Oh, by the way, they put the Z function at the bottom. And that's the problem with the notes and the calculator. The notes put the objective function at the bottom while the calculator puts it on top. So you got to know your calculator. If you can find a calculator that goes according to the notes, well, all well and good. But remember, I have to work with what I find on the internet, right? That's the best I can do. Good. So notice they put the objective function at the bottom, right? They put 12, 16, and well, the initial value is 0. And then you put 1, 2, and 40 there, and then you put 1, 1, and 30 here. What we do now, we take this matrix and we find the transpose. Look here. Look here. You see that this is the transpose of this? And I'm hoping that you remember some matrices. Good. Do you see it? Anybody telling me something that you're seeing it? Seeing it?
Yes, sir.
Rows become columns and columns become rows, right? When you watch back the video, you'll take some time and yeah. Now, when you find this transpose now, take these coefficients and what happens now? Make it into a maximization problem. So notice what we do. So Z is equals to now 40Y. Notice they're not using X1 and X2 because they're not the same thing. So you have now Y1 and Y2. And you take the coefficients in that matrix and make up the constraints now, right? Y1 plus Y2 is less than or equal to 12, Y1, 2Y1 plus Y2 is less than 16. And of course, the non-negativity constraints are always present, right? Good. So when we take this now, we can now put this in the simplex. As a matter of fact, they did it here. They use the graphical approach first of all. And you can see this is a solution if you were to do it using the graph. So the minimum value of the objective function is 400. And it occurs when x1 equal 20 and x2 equal 10. Right? However, when we take the maximization problem and solve it, we have a little situation where, okay, we do get the 400 as the value. But notice y1 and y2 takes on 4 and 8. Those are not the values at which the minimum occurs. Those are the transposed variables. So those are not our solution. The value of 400 is the minimum, right? It is the minimum. However, 4 and 8 is not when it occurs, right? That is when the maximum occurs. So these conditions here, but that's not when the minimum occurs. The method of the graphical approach just doesn't reveal that. However, it can be seen in the simplex calculator, right? And okay, they're stating the principle here that to solve a minimization problem, right, you can find that minimum by transposing the problem into a maximum problem, right? And the maximum and the minimum are going to be the same range, right? If the problem that you turn into a maximum, whatever value you have as a maximum is also the solution to the minimum problem. The only thing you're not getting, right? You see from the graphical approach, you're not getting when that minimum occurs. There's a conflict, right? However, this writer, and I'm going to take these notes and make it available to you. I have to do it before the week is out, so you can get to read over the thing. So notice they're taking the same problem, change it to a maximum, and you're going to use the simplex here. And they're doing it a little differently from the calculator, right? They're doing it a little differently. And notice what happens when you finish. So notice they have their z function at the bottom here, right? And do you notice the solution here is 400 is the minimum, but you're not taking the solution to be the 8 and the 4. You're taking the 20 and the 10. So reading off that is a little fun. You are used to saying, oh, 8 and 4 are supposed to be the values of x1 and y1 when the minimum occurs, but no. 8 and 4 is when the maximum occurs. However, we're going to take the 20 and the 10. The reading off is a little different. That's the only difference. Right? So just keep that in mind. I want to go over, you think you're following what I'm saying?
Yes, sir.
Good. I want to go over to the simplex calculator where I actually use the maximum. I transform the thing and I'm going to solve this maximum problem using the calculator, right? Let me see if I can find it quickly. Oh, not that one. I think this one. Right. So here it is. Watch. Notice I change it to a maximum problem, right? Change it to a maximum problem. Notice there's no greater than sign here. There's no greater than sign. It's a less than sign, right? The objective function is changed as well. I click on maximize and I did my calculation. And we're not going to go through the steps, right? We went through that in just now already. You are going to go through it in your own sweet time. You could type this in the internet and get the answer. Let's scroll down to the solution. So here is your solution. And I know that the tendency will be to say that your solution is 400, right? And your x and y values are going to be these. However, I'm telling you, disregard this solution and use these two numbers. right? Right? Use this number as your x1 and this number as your x2, right? As your solution. Notice they even give 4 and 8, right? But don't use that. Really and truly, we're concerned more with the minimum value, 400, right? But don't use the 40, use the 20 and the 10, right? And of course, you can actually solve the minimum problem directly using the calculator. I showed you a calculator. It's just that one get a whole set of M and so inside. And that might confuse you and say, where does M thing come from? Right? And the arithmetic involve a lot of algebra. And that can very well give you a hard time. I mean, you don't have to know it. The calculator is doing it anyway. Right? So you think you follow that? Let me go back to what the people are telling you. Take your minimization problem. Right? Let me go back to the top. Let me go back here. Take your minimization problem. Oh, by the way, this one just has 2 unknowns, right? Someday you can get 3 unknowns. Right? And when you have that, you can't use the graph to check it. You can't use the graph. You will have to depend on the simplex, right? So notice you take the minimization problem, make a matrix, right? If you want to put your objective function on top, that's no problem. You can do that too. But these people put it at the bottom, right? They put it at the bottom. Remember, every writer is minding their own business. This writer, they don't know that somebody is writing a calculator somewhere else where they'll put the Z function on top. But they are counting that the reader has got some amount of intelligence, and they will know that, oh, man, the only difference is that, they put the Z function at the bottom, but this calculator puts it on top, right? So I'm counting that you all got some amount of common sense, you got some amount of insight, and you know that, man, the only thing is that sort of confusing us. But the people just move it a little differently. That's all. Good. So you take the initial or minimization matrix and transpose it. Take the row, make it into a column. 1, 2, 4, 40 is the first row. That becomes the first column, 1, 2, 40. 1, 130 is the second row. Make that into your second column, 1, 130. 12, 16, and 0 was your third row. Make it into your fourth column. Take these coefficients now and make a maximization problem. Right? Make a maximization problem. Here it is. Right? You can go home, and when you watch the video back, you will see that these coefficients are in the right place here. Notice we flip the Z function and put it on top. The objective function is on top. You don't get confused easily and start to quarrel. How they got up on top again? Right? Don't always be quarreling about stuff. Try to figure stuff out. Right? Lots of times some of you are studying accounting, and when you go into the real world, right? Lots of times, you go into I'll tell you something now. All right, let me not tell you. Because it might raise a whole controversy and so about tests and all that. Anyway, yeah, you might be taught stuff in the class about, when you're doing accounting and all of that, right? And when you go into the real world, you see the people doing accounting differently. You go into a forum and they tell the foreman, but this now I learned it in school. They say, hey, you just come. You just come. We've been doing this thing this way, and we understand it that way, and we have gotten people to write software, to suit us. You can't tell the people they gotta change to suit you. You're just a speck of dust, a drop of water. You're a small cockroach in the business. You just go there. You can't try to, if people say you want to go home, you don't want to come back next week. So you have to adjust, right? You have to learn the people's ways quickly too. Because with all your fancy degree, when you get distinction, you go in and people say that you don't know nothing. Because you can't follow this little thing here. You only change up the row and change up the column and so on. That is what you can't figure out, So you have to quickly adjust. You understand? Yeah. So learn to adapt quickly. When you see it, you say, what really happening? How does that thing go on top now? Or that. It goes on top so well. Right? Now you take this maximization problem and you take it into the simplex calculator. In the notes here, the people actually do it, right? Let me skip over. They actually make up they're doing a little differently. The y1 and y2 are the unknowns, and x1 and x2 here are actually the slack variables, right? That's what they're doing here, right? They actually are making them into slack variables, right? So I think it's the writer here, notice I say what? The slack variables are x1 and x2. It's kind of confusing, right? It's kind of confusing. But notice at the end, watch here. When you finish with the whole simplex thing, right? Watch here. Notice x1 and x2, the bottom here, x1 is 20 and x2 is 10. It helps with the reading off of the solution, you see? So they use S1 and S2 as the slack variable. They use X1 and X2 as the slack variable. So the slack variable for the maximization problem is really the solution of the minimization problem. Do I sound confusing?
A little, sir.
Yeah. But when you listen it back, you're using the variables, the unknowns for the minimization problem as slack variables for the maximization problem. That's why when you're reading off the solution, don't read off the 8 and the 4. No. Read off the 20 and the 10 because notice x1 is here, x2 is here. So your solution is x1 equal 20, x2 equal 10. And your minimum is 400. Your maximum is also 400. Right? And that's why if we go back, I think when we go to the simplex calculator, let me see here. Not this one, it's this one. Notice S1, S2 I use here. Remember the calculator names the variable. According to their programming, they use S1, S2. Then they use X1 and X2. Right? So I can't fight with them. I have to know what I did. Now you notice I didn't even use, I was supposed to use Y1 and Y2 here, but I use X and Y because I noticed typing in X1 and X2 in this program gives me some trouble, right? And that's why I had some difficulty with it. That's why I use X and Y, right? So that is why I'm saying must practice some of these things with the program. Because come the night of the test, you better know to use your calculator, right? You have to know to use the calculator. You got to understand, oh, this S1 and S2 is really the solution to the, what do you call it? The minimization problem, right? As well as, notice the Z on top. In the notes, the guy put it at the bottom, right? So you must know where things are. Do you think you get it?
Yes,
So
sir.
I have this thing recorded, so I'm going to make it available to the class. As well as I said, I already have 2 videos of 2 other tutorials, and I want to feel in those tutorials, I may have made an error when it comes to reading off the solution to this minimization problem. So this video will kind of correct it. I myself, you see what happens? I just see the calculator, I jump on it, and I misread its answers. You see, so even me, I'm not glad I can make mistakes. I keep telling people that, right? And because I saw the calculator, I like it quick, and I jumped on it, but I misread the solution, I think, in one of those videos, or maybe both, right? So I may have to take those videos, chop out that piece, and splice it or something, you know? I just know you have to show people watching, man, I know what you're talking about, you know? So people, students can do that, you know? And that's why I don't like to post all these videos all over the place. I don't know what people are doing with it. People take it and use it all against me and all. All right, good. So can we stop there then? Everything you think the two examples we did were clear?
Yes, sir.
Good. So remember, if you want to use this calculator, no problem. You're free to use it. Mind you, there are lots of powerful ones out there, right? You can search around if you also desire. And then there are all these AI things that are out there that can solve some of these problems that, very easily. And so, but please know the process because I'm going to have a lot of little questions, a 1 mark question, a 2 mark question on, on, on the process, you know. And if I give you a table, I can give you a table like this. Give you a table. Say, all right, which is the pivot column? And you got to know which column, right? Which is the pivot row? Which is what is the pivot element? I know what this man talking about, right? So you got to know little things, right? You got to know how to draw an inequality on a graph. You got to know how to draw a line, in fact, right? If you're given a line, you got to be able to draw it. So all those things you got to know, right? So those are little questions I can ask. So be prepared for all of that. So our test is going to be next Saturday, right? Saturday the 14th. I'm going to have more than one test. As you know, some people, all kinds of things is happening. So I'm going to put out some information to that effect before before Tuesday, I think. Right? Fit yourself in one of the groups to write the test. All right. So we'll stop there.